Hi, I'm Doug Smith, and I'm just putting the finishing touches on a video I'm working on switching power supply noise and specifically magnetic field radiation. This has caused all kinds of problems in the field, so let's watch the video and I'll come back afterwards and we can discuss it. So here's our experiment table. I have a small switching power supply. It's an 8 amp 12 volt unit. And we have the oscilloscope, which is an Agilent DSO 5054A. 500 megahertz scope, and we have a 50 watt 12 volt work lamp. It'll act as a load on this 12 volt supply. And as you can see, if I reach down and turn it on here, it comes on rather brightly. In fact, I'm going to have to turn this down like that so I don't get light in the camera and in my face. Hopefully it won't set the tablecloth on fire here. Okay, so let's look at what's going on here. What I'm going to do with the power supply unloaded, and we're going to see what happens on the scope up there, and we'll come in a little closer here. Put the power supply right up in front of the scope. As I bring the loop above the power supply, and again, essentially I'm using a square loop to pick up the magnetic field, we're seeing maybe 150 millivolts there on the scope. Now let me turn the light on. And let's do the same thing again. Quite a bit. Right over the power transformer there. Right about in there. Let's see if we can maximize it. There, right there. And if we go up onto the scope, we can see almost 400 millivolts full scale. And again, the horizontal scale is 50 nanoseconds per division. That's a lot of magnetic field. Watch what happens if I go down on this wire here. Let's see if we can come around here and see this. There's a wire coming out of the power transformer. When I look on the scope, way off the screen, I think it's like a volt or two in the loop. Not sure, but it's quite big. So there's a lot of current in that wire right there, and that's some of the magnetic emissions, and some is probably leakage from this transformer. But now, just imagine that we have a small analog circuit right about here above this power supply, what we're going to pick up in it, or even a digital circuit. I mean, if you look back up at the scope, that's nearly half a volt. That's certainly enough to interfere potentially with some digital circuits, certainly sensitive ones like phase lock loops, but even regular logic signals. So this is an example of measuring the magnetic field emissions from a power supply with simply a loop. Well, that was an interesting video. And if you notice, my little 1-inch square loop, and of course it doesn't have to be square, my little 1-inch loop picked up something on the order of 400 millivolts from that power supply when it was under load. That's a lot of voltage. And one of the advantages of this measurement method that I've shown you, compared to the normal way of specifying this, which would be to measure the magnetic field over a frequency range, the problem I have with that is, how do I get from a magnetic field to a voltage? I have to assume a geometry, go to some books, look up some constants and equations and things, possibly even do some integration, and an hour or two later I come up with my answer of X millivolts or volts in the circuit. Well, that little loop does all of that for you automatically. I have a small loop, in this case a 1-inch loop, through 50 ohm coax to the 50 ohm input in a scope, and the voltage that comes out of that would be very similar to the voltage that field would induce in nearby conductors. If I had a wire passing over the top of that power supply, that's actually a larger loop. It'll probably pick up more than the 400 millivolts. In addition, we could think of a two-layer board over top the power supply mounted in the equipment. And if the loops formed by the signals or grounds or powers in that board were on the order of the size of my loop, I'd pick up 400 millivolts, which is probably enough to disturb the signal. So the output of the loop gives me a feeling for how it will affect equipment. I'm getting hundreds of millivolts of noise into a small loop like that. That's probably too much. And I've seen as high as 4 volts with some supplies, about 10 times what we saw in this one. That was a really bad one, and I've had several of those. So I like this way of measuring the magnetic radiation, and I think it is more meaningful than measuring the magnetic field with a calibrated probe and then converting eventually through some geometry to voltage in the circuit. Okay, I hope you enjoyed the video, and there'll be more coming. Thanks.